Okay, 6.1. Solving one-step linear inequalities. Okay, now, I don't know. I mean, they're the things that are done are not a whole lot different now. Now, the problems, obviously, word problems, things like that change, but the overall gist of it, I've got some there from 1902 that are very similar to the problems we do in here. A lot smaller as far as the size of the book, but it's still thick and pretty much do the same thing. All right, now let's talk about our inequality signs. First of all, okay, there's your 4 basic inequality signs. Okay, the first one here is less than or equal to. The second one is greater than or equal to. The third one is less than. Fourth one is greater than. Okay, those are the 4 inequality signs that you have. Basically, what we're talking about today is this. Instead of having an equation of x plus 5 equal 3, okay, we're going to have, once again, this is an equation. What we're going to have is an inequality. The inequality will look like this. X plus 5 is greater than or equal to 3. That's the difference between what we're doing from previous chapters and what we're doing in this chapter. Okay, now, obviously, when you look at equations and the difference between equations and inequalities, the equation here, x would be equal to negative 2. Okay, here, x is greater than or equal to negative 2. Okay, so here you could have basically, if I drew a number line, this being negative 2, negative 1, 0, 1, 2, 3, 4. Basically what you have is this. Here's negative 2, and anything to the right would be a solution. Now, you will notice that my dot is colored in. Okay, the reason that this right here is colored in is because of the bottom part of that sign. Okay, if that would have said x plus 5 greater than 3 is greater than 3, then x would be greater than negative 2. How you would do that one would be this way. Okay, that's how you would do that one. You notice here that the circle is not colored in. Okay, that's how you would graph the solution to both of those inequalities. Okay, if it includes half of the equal sign, then the dot is colored in. Okay, if that would have been x plus 5 is less than or equal to 3, that would be x is less than or equal to negative 2. Then how I would graph that solution would be that right there. Since it points to the left, less than, then the arrow goes to the left on our graphing of the solution. Okay, you will notice up here that my arrow was pointing to the right, so therefore my arrow here is pointing to the right. Okay, and that's one way that you can tell. Whichever way the less than or greater than sign is pointing, then that's the way you've got to do it. Now, so how would I graph x greater than negative 2? Caleb. So we'd have this, and it would look like that. Now, the green line's really supposed to be on the red line, but just for our purposes, since it's hard to sometimes do that, just put it above it like it is there. Because I know most of the time, you're going to have a bunch of colored pencils and all that. So just put it above it so you can see it. Because obviously, if I did the number line and then did the solution in the same color and put it on the line, then it'd be very difficult to tell where it is. Okay, but that's how you would graph. That's how you graph x is greater than negative 2. If it was x greater than or equal to negative 2, you want to graph that, then it's the same thing. It's the same thing, except now you would color the dot in, and it would go there. Okay, it's still to the right. Once again, the difference is that right there. Since it has that, you've got to color the dot in. Since there was nothing here, that's why we didn't color the dot in there. So that's how you graph that inequality. Okay, now, how we solve the inequalities exactly the same way we did equations. Okay, for example, if I had -5 less than is less than 4 plus x. Okay, well, to solve that, we simply subtract 4 from both sides. Or if you want to look at it this way, here it's a positive, here it's a positive, here it becomes a negative. Okay, and we add. Either way, you're going to come up with the same answer, because that is x greater than -5 minus 4, which is plus a negative, which is -9. So x is greater than -9. Okay, how you graph that? Okay, remember to read this properly. X is greater than -9. So if this is -10, -9, -8, -7, -6, be that right there. X is greater than -9. No. It's because the way that is, in other words, this and that are the same expression. Those are equivalent inequalities. You have to read it properly. Okay? This is read x is greater than -9. Or -9 is less than x. Okay, that's the two ways that is read. Okay, now, the actual solution, what we say to this problem, all real numbers greater than -9. That's how you would say the solution to this inequality. All real numbers greater than -9. So this is how you read the solution, and this is how you graph the solution. Okay? Most of the time, they're simply going to want this and this. Okay? Most of the time, they're not going to have you write out your solution. Caleb, did I answer your question? Okay. All right. Now, that and this are the same thing. The reason they're the same is because the mouth is open to the 6, the -6, and the mouth is open to the -6 there. Okay, so you can flip them if it's easier for you to solve, having the variable and the stuff on the left side instead of the right side. Go ahead, but it's the same expression. Okay, now, to solve this, we have to add 4 to both sides. So what is -6 plus 4? Negative 2. Wow, I picked another one with negative 2 as the answer. Okay, so that says negative 2 is greater than x, or x is less than negative 2. So, to graph that, that's not colored in. It looks like it is, but it's not. Okay, so that is x less than negative 2. Okay, and so this and this would be your answers. Caleb.
So when it says solve the inequality extracted solution, x is less than negative 2, solve for negative 2 is greater than x, to solving the inequality?
Correct. Yeah, that is your solution to that expression. All right, do this one on your own.
You want to graph it?
Yep. Negative 8 is less than or equal to x minus 14. Yeah, I can't do my sign proper. There we go. Remember, once again, this would be the same thing. Caleb, what'd you get?
I got x is greater than or equal to 6.
Yes. X is greater than or equal to 6. Okay, the reason that is true, you have add 14 to both sides. Cancels over here, giving me negative 8 plus 14, which is 6, and then that right there. Once again, you do it over here, you get the same answer. It's just actually expressed as reading from left to right instead of reading right to left. Okay, now, to graph it, obviously, you'd have your graph, and you would have 5, 6, 7, 8, 9, and then we graph it as that right there. Once again, it's colored in because this part of the sign right there. All right. Yes, Brianna? I could have. You could have done that, be plus a negative, then take this over here. It's a negative here, so it becomes a positive there. So you have positive 14. Still going to get the same answer either way. Whichever way you prefer. Now, the next thing, 15p less than 60. Okay, solve this same way we do equations. We're multiplying by 15, so the inverse operation of multiplication is divide. So I'm going to divide by 15 to both sides. That gives me p is less than 4. Then you graph it. Now, here's where it becomes a little bit different. Negative 10a is greater than 100. So how do I solve that one? Larry, what do I do to solve that one? Okay, we're going to divide negative 10 to both sides. That gives me a is greater than what? Negative 10. So, Matt Shelton, give me a number that's greater than negative 10. Okay, negative 9. So let's plug that in and see if it works. Negative 10 times negative 9 is greater than 100. 90 greater than 100. Is that a true statement? No. That isn't true. So something we've done up here is wrong. What do you think, Blake? There you go. Once the negative, when you multiply or divide by a negative number, you must reverse the inequality sign. Okay, the key being here, negative, multiply, or divide. It is only when you multiply or divide an inequality to solve it, to solve an inequality, when you multiply or divide by a negative, not a positive, not adding or subtracting a negative, it is simply multiplying or dividing a negative, you must reverse that sign. So, negative 10a greater than 100 means this. Divide by negative 10, divide by negative 10, that gives me a is less than negative 10. And that is your actual answer to the problem. If you would have had this, 10a greater than 100. We divide by 10, a would be greater than 10. That is correct. That is the answer. Okay? So, if we check this, what is a number that is less than negative 10? Larry, negative 11. So if I plug that in, negative 10 times negative 11 is greater than 100. Negative 10 times negative 11 would give me a positive 110 that is greater than 100. So it does check.
85 billion.
Do what? That is just to show you, this is just an example. It's an example of if you, I didn't solve by dividing by a negative. I solved by dividing by a positive, so the sign stays the same. I just made it up. Okay? Just to show you that this and that sign stay the same there. Here we reversed it. Okay, so I want you to try this one. The answer to the problem that we're going to have in the work is a less than negative 10. All right, look at this one. 2.1x is less than or equal to negative 10.5. Solve it. Yep. Nope, actually these you don't have to graph. All right. Brandon?
X is less than or equal to 5.
No.
Greater than or equal to.
Oh, wait, yeah. It's not just...
Zach?
Negative. Okay, bubble. X is greater than or equal to negative 5.
No. Owen? Yes. X is less than or equal to negative 5. You are dividing by a positive 2.1. So this stays the same. And the reason Brandon's wasn't correct because he just said X is less than or equal to 5. It's not positive, it's negative 5. No, I'm not adding or subtracting. Ella.
I just have a question about which way you draw the arrow, like whenever you make the graph.
When you graph it, it's going to depend on how that is written. Okay, so if I was doing this one, it would be like this, negative 6, negative 5, negative 4. Okay, if I was doing this one, X is less than, so this is X is less than or equal to. Okay, so that one would be right here, and it would go to the left because of the words less than. Okay, if this was X greater than or equal to negative 5, so I read this one, X is greater than or equal to because of the words greater than, then this one would be -6, -5, -4. That one would be, because of the words greater than, the arrow would go to the right.
Is it wrong if you like switched it around and made it like X is, or like -5 is greater than X? If you did that in
On which problem? Those are two different problems. The first one,
the first one.
if you said this, -5 is greater than or equal to X, that's not wrong, but the problem you've got is this. You can't say that is greater than and switch this here. You can't do that. That would be wrong. Okay? That's why I always try to write it as X being first, is less than or is greater than, then the number. That's why I always try to put the X first. Okay?
So if you put the variable first, the arrow's going to go the way the sign points?
Yes. If the variable is first, then the arrow is going to way the inequality sign points, if it's listed first. Okay? If this was, let's say it was like this. Let's say it was that. Okay? That says X is greater than. Okay? So when it's on the right side, your variable is going to point the opposite way of the inequality sign. Okay? When it's on the right side, okay, the arrow, well, not 3 R's, the arrow will be opposite of the point on the inequality. Okay? Now, your homework.
Oh, wait, don't say it yet. 22 through 50 through 60.
Nope, I got to look it up.
54 through 54. 60 is pretty funny. 1 through 6. I mean, 1 through 45. Oh, 22 through 1 through 5.
All right. 6.1. 11. What's that, Matthew? That's why I said it, because you were being a snob. I'm going to change it. Originally had given you more than I'm going to give you. 22 through 60 even. Originally it was 10 through 60 even. 22 through 60 even, and then 62 through 67. That's good, because I make up my homework assignment so students will be okay with it.